Good evening, Prithviraj. Am I audible?
Yes, sir.
Okay. So we'll wait for 2 more minutes, then let other people also join.
Okay. Take a second.
So Prithviraj, we are going to discuss few numerical problems also. So for that you need to arrange calculator, notebook, and everything, whatever the stuffs needed for to solve the problems. Please arrange yourself.
Yes, sir.
Good evening, Srikanth. So today in this week two session, we are going to solve some numerical problems. So please arrange all the notebooks, pens, calculators, whatever the stuff required to solve the numericals. Please arrange yourself. We'll just 1 or 2 more minutes. Wait for 2 more minutes. Attendance. Okay, Prudviraj and Srikant, shall we start?
Yes.
Okay. Okay, shall we start? So you are able to see my screen, right? My voice is clear, right? Okay. So again, we are discussing about environmental remediation of contaminated sites. So the course instructor name is Dr. Banu Prakash Velanki. So myself, I am S.V. Chinnaswamy Naik, a PMRF scholar from IIT Roorkee. So today also we'll going to discuss week 2 sessions, few brief introduction of week 2 session, whatever the course instructor taught in the class in the FPTL course in week 2 classes, and unrelated questions, previous year week 2 related content related course questions we'll solve. Hmm. So coming to the overview. So in week 2, in the first video from the beginning, course instructor was teaching like dose response relationship. So dose response relationship for carcinogens and non-carcinogens. So here you guys already before in from week 1 onwards we are talking about this dose response relationship. So in that, like, we just draw the um, curve with respect to dose versus severity, dose from on x-axis and severity on y-axis. So from that, we draw for different this dose response relation curve for carcinogens and non-carcinogens. From that we will get like what is the threshold dose, what is the what at what point we are taking the no observable adverse levels of adverse effect levels, and lowest observable adverse effect levels. So like course instructor taught in the class like NOAEL, LOAEL, and threshold doses. So after that, course instructor was teaching about uh, uns- uncertainty factors. Okay, three people joined in live session. So again, I'm telling all people, please arrange calculator, notebooks, pen and paper. For we are going to solve a few numerical questions. Small, just small numerical questions only. Those are not simple numerical questions, not complicated one. So okay, you guys are you guys able to see PDF, right? Okay, So we are discussing about again uncertainty factor. So to calculate the safe level or response dose, we need based on uncertainty factor, we calculate the response dose, right? So 1 minute. Okay. So based on uncertainty factor, we are going to calculate reference doses. Like again, how do we calculate reference doses? Based on LOAEL or NOAEL upon uncertainty factor. So generally uncertainty factor we take mostly for 10 for different conditions for human variability, because what humans which are working on contaminated sites, so their weight will be their mass will be different, so age will be different. So such variability we are considering the certain factors. So for different factors we are considering uncertainty factor equal to 10 for human variability, again a 10 for extrapolation from animal to humans. Again we are taking 10 for use of less than chronic data, again for using NOAEL instead of LOAEL. So again we are considering uncertainty factor 10. So these things are discussed in the uh, week 2 session. After that again safe level or reference doses. So say how you will calculate safe level or reference dose. So already the formula given, right, that is LOAEL. So please note down the formulas also, it might be helpful for you while solving the problems. LOAEL or NOAEL upon uncertainty factor. So for calculating the reference dose. Okay, so how we calculate reference dose? Based on LOAEL or NOAEL upon uncertainty factor. So again, what is this LOAEL and NOAEL? So LOAEL is the lowest observed adverse effect level. So that point we'll get from the dose response curve. Okay, so we similarly NOEL, again we get it from dose response curve. What is NOEL? No observable adverse effect level. Okay, again uncertainty factor we already discussed what are the different uncertainty factors we have to consider for calculating the safe level or reference doses. Next, exposure measurement, sorry, exposure assessment. So exposure assessment we discussed on the contaminated sites. So again for that for exposure assessment also we can there is a formula that is called exposure equal to intensity into frequency into duration. So I'll try to write it, so you people also note it down, so it might be helpful for you. So exposure, for calculating exposure, what are the things we need? Intensity multiplied frequency multiplied duration. So it generally refers how much, how often, how long uh, these these three parameters represent. Intensity represent, sorry, 1 minute please. Okay, so as of now four students joined in the live session. Okay, so coming to the point, we are discussing exposure, right? So how we will calculate exposure? Like based on intensity, frequency, and duration. So how these parameter describes intensity describes how much, and frequency describes how often. So and duration how long. So again, for this we need to calculate this reference doses or safe level or hazard index or lifetime cancer risk. For calculating these things we need intake. So how much carcinogens or toxic compounds are intaken by different condition like thermal ingestion by the human being, right? So for that intake is different important parameter. For this one also we have to consider. So for again for intake, again what is the formula? Intake, generally intake we measure in milligram of carcinogens or toxic compound consumed by human in milligrams per kg of soil per day. Okay, so the formula refers CE. Actually it is Ce suffix e. Okay, Ce is the exposure concentration. Okay, it is measured in milligram per liter. And next is Ri. R suffix I. So Ri represent intake rate. So generally it measure we measure in liter per day. And similarly EF. EF is the, anyone? You people already attended the classes, right? What is the EF? EF is the exposure frequency. Generally it is in days per year. So number of days in a year uh, uh, this human being spend the time on contaminated side or worked on contaminated side, days per year. And next ED. See guys, my job is not to solve all these questions. So my job is to make you guys solve these questions. So for that you guys should come with some preparation, like at least some formulas, whatever the things you noted down in while during the NPTEL classes. Okay, so again ED is, anyone please? ED is the exposure duration. Generally we calculate ED in years, and then BW upon BW. What is the BW? Yes, it is the body mass. And AT. So note down these formulas, all these formulas, so that while solving cross numericals, it might helpful for you. Okay, so what is ET? Sorry, AT average times. Again, AT we measure in days only itself. But sometimes what we do for non-carcinogens, average time we took are equal to the exposure duration. Okay, but generally most of the times average time we consider around 70 years for carcinogens conditions. Okay. Okay, after intake, again course instructor was discussed about hazard quotient, right? Hazard quotient or hazard index, nothing but both are both hazard quotient and hazard index represent same thing. So hazard quotient or hazard index and lifetime cancer risk. Okay, so how we will calculate hazard quotient? Hazard quotient or hazard index? So generally hazard coefficient or hazard index, we use it for non-carcinogens, and lifetime cancer risk for carcinogens. Okay, so for in week 1 also we discuss what are different parameters which represents the non-carcinogens used. This parameter used to calculate the non-carcinogens concentration and carcinogen risk. Okay, calculating the risk assessment of carcinogens and non-carcinogens. So hazard index, we use it for non-carcinogens, and LCR or lifetime cancer risk, we use it for carcinogens. Again, so these are there are two factors we already know in the first week itself. So we discussed that is there are two variables for toxic and carcinogenic to may assess the risk assessment to assess the risk. So reference dose we use it for non-carcinogens, and slow factor we use it for carcinogens. Okay, so already one question was also came in week 1 assignment, so we already discussed about it. So how we calculate hazard index or hazard coefficient? Intake by intake, already we discussed how to calculate the intake, right? And intake generally we calculate in milligram ingest milligram of carcinogens or non-carcinogens ingested by the human per kg of soil per day. Okay, so hazard coefficient we calculate intake by intake upon reference dose. So already we discussed how to calculate the reference dose. So here LOEL or NOEL upon uncertainty factor. So it generally hazard coefficient we use it for non-carcinogens. Okay, and similarly LCR, lifetime cancer risk. So similar formula, but same. But what are the what is the factor we used for carcinogens? Slope or reference dose? Slope factor or reference dose? So for lifetime cancer risk, we calculate lifetime cancer risk by intake multiplied by slope factor. Okay, and then again soil ingestion. Again for soil ingestion also intake we have to calculate. Again there is a formula. It is C into, should I write or no need? Do you guys have formulas with you? Have? Okay, okay, I'll write then. Okay, please try to note it down so that we can it will be helpful for you. Okay, soil ingestion. Again for soil ingestion intake. This intake for soil ingestion. Okay, so please tell me if you are not able to understand the writing, because I am using mouse, so it is not comfortable to write. But still, it's okay, right? Okay, if you are not able to understand anything, then just let me know. Then I'll try to rewrite it. Okay, okay. Again, C upon E, soil ingestion intake for calculating. It is C upon E multiplied by RG, R upon G. So RG and CF. See here again, CE means against exposure concentration in soil. So again we measure in milligram per kg, and RG is the soil ingestion rate. So how much milligram of carcinogens or toxic compounds are there? Sorry, consumed. Whatever the soil contaminated soil. I mean contaminated soil consumed by the human being during the work per day. So like by thermal contact or ingestion or inhalation, with these contacts there are the chances of ingestion of this contaminated soil by the human being. So that represents soil ingestion rate milligram per day. So and then cf c suffix f. Okay, what is again cf? Conversion. It is the conversion factor. Generally we represent it 10 power minus 6 kg per milligram. And then fi. So f suffix I. So f suffix I represent fraction of ingested soil that is from contaminated site. Okay, multiplied by, so ef, again ef already you know, exposure frequency, number of days per year. Okay, so ef and then ed also you guys know, we discussed earlier. Ed, what is ed? Yes, exposure duration. So upon, similarly again bw, what is bw? Body mass and at, average time. Okay, this is the formula for soil injection intake. Okay, these things again here also similar case. For non-carcinogens we consider like average time equal to exposure duration, and similarly average time equal to lifetime. In case of carcinogens, what we consider in exposure assessment, average time equal to 70 years, but in case of the soil ingestion we consider its lifetime, average time equal to lifetime. Okay, and then shall I erase the soil ingestion intake formula? Okay, and then after soil ingestion, there are two important concepts deterministic approach and stochastic approach. So in deterministic approach we generally go with a particular selected point data, and in stochastic approach based on the distributions, like different distributions we discussed, like probability distribution functions. Course instruction taught about normal distributions and natural logarithmic natural lag normal distributions, right? Based on the probability distribution function we calculate the stochastic, we go for stochastic approach, and based on the point data we go in deterministic approach we go with point data, and in stochastic approach we go with distribution, probability distribution. Like they discuss about standard deviation, mean, standard deviation. So probability curve also there, course instructor taught in the course. So after that TCLP test. So in the week one also we discussed briefly about TCLP test. So it is a TCLP. What is the TCLP abbreviation, please? Anyone? Any idea? So it is the toxicity characteristic leaching procedure test. Okay, so whatever the heavy metals or any toxic compounds, to find the toxic compounds present in the soil, so we do test TCLP test to find these toxic compound concentrations. Okay, so regarding TCLP test he discussed for doing TCLP test, if the particle size of the soil is greater than 9 mm, then we have to crush the soil particle less than 9 mm, and then we have to maintain the equilibrium condition with acetic acid, because why you use acetic acid, because this acetic acid is expected to form in anaerobic condition in the municipal solid waste. So further, in equilibrium, to maintain the equilibrium condition, we use acetic acid in TCLP test. Okay, so after that, what are the method also he mentioned, like test method for evaluation of solid waste. That one test method 1311, he just mentioned the test name. And the liquid solid ratio, what are the liquid solid ratio we need to maintain for the TCLP test, that is 20 ml for liquid ratio for 1 gram of soil. Okay, after that, after maintaining this liquid ratio, we do for go for end over end tumbling. It is nothing but kind of rotating after mixing this, maintaining this proper proportion of solid and liquid. And then we go for tumbling, nothing but just rotating the liquid sample with end over end mix for 18 hours. And then after 18 hours, we extract the whatever the toxic compounds or heavy metal compounds are present in the soil. It will be leached into the liquid, and then we'll extract the liquid, and this whatever the extracted liquid we collect and collect it, and we do the testing by using there is an instrument called ICP-MS. With that, we will it will this instrument will give the heavy metal concentration. Based on that, we'll get the concentration. Based on concentration, we do the some risk assessment. Okay, and then hazardous rules and regulations. So in week 1 also briefly he discussed about hazardous and other waste rules and regulations. So again, he in week 2 he specifically highlighted few points, important rules. So there different waste management rules also he discussed, like plastic waste management rules 2016, and it is amended in 2018. Again, e-waste management rules 2016, biomedical waste management rule 2016, construction and demolition waste management rules 2016, hazardous and other waste management or transboundary management rules 2016. So coming to the hazardous waste management rules, generally it is important, like he discussed there, like regarding safe handling, generation, processing, treatment, package, storage, transportation, use, reprocessing, collection, conversion, offering for sale, destruction, and disposal of hazardous waste. So and final one is first come into effect in the year of 1981. What is the okay? Am I audible to everyone? Yeah, the session seems like silent, so I was I got doubt, like. Okay, we'll continue. Okay, then after that, what we discussed, what course instructor discussed in the class. So hazard waste, the definition of hazardous waste. The what is the definition of hazardous waste? The hazardous waste is any waste which by reason for characteristic that causes a danger to health or environment called hazardous waste. Again, it's depend upon their physical, chemical, biological, and reactive, toxic, flammable, explosive, and corrosive characteristics. Okay, so coming to the other waste. So other than the hazardous waste, whatever the waste which are like tire, paper waste, metal, scrap used in electronic items, those waste comes under other waste other than the hazardous. So and then next thing we discuss about problems of unscientific disposal of hazardous and other waste. Problems of unscientific disposal of hazardous and other waste. So what are the problems of unscientific disposal, especially focusing on Indian context? So they are simply burning. So these waste is not collecting properly, not managing handling or managing properly, they are just burning. So some unscientific ways, like burning, nothing but we used to in technically we call it is incineration. So disposal in waste bodies, are in municipal dumps, so we can't we should not dump the hazardous waste directly into the municipal solid waste. So again, these are the some unscientific disposal, and the worker employed in such unscientific practices suffer from the neurological disorders and skin diseases, genetic defects, and cancer, and etc. So these things, these disposal system needs for a systematic management in an environmental sound manner. Okay, and then construction process for new hazardous and other waste rules. Construction process for new hazardous other waste rules also he discussed, just I'm not going to deep into it. And then finally the waste management hierarchy. So what is the waste management hierarchy? First one is prevention. Of course, prevention is better than the curing. So prevention, and then minimization, reuse, recycling, co-processing, and safe disposal. Okay, so these are the content discussed in week two session by the course instructor. So we already completed half an hour live session. So now we'll move to the previous year assignment questions. Okay, so before that, let me confirm few things. Do you guys have any doubts? So if you have any doubt, okay. So I'm not going this time. I'm not going to solve any problem or any question. So you guys should answer everything. So my job is to make you solve these assignment questions, not to solve the assignment question. My job is to make you solve these questions. Okay. So just I'll help you. Just try to solve. Try to just give your opinion on the question. Okay. The first question. Select the correct uncertainty factors used for risk assessment of non-carcinogenic effects. So already we discussed like what are the uncertainty factor we consider. We generally consider uncertainty factor 10 for different conditions. So here the question is they're asking select the correct uncertainty factor used for risk assessment of non-carcinogenic effects. Okay, so uncertainty factor is 10 for human variability. Is it true? Right. Okay. Nice. Answer one is true. And uncertainty factor is equal to 10 for extrapolation from animals to humans. Is it true? Yes. True. And next one, uncertainty factor is 10 for use of more chronic data. Is it true? True. Think again. I need everyone's opinion. Okay, not single person. Just please everybody involved. So Kirtana, Prithviraj, Srikanth, Vinod. So what is your opinion, guys? Uncertainty factor 10 for use of more chronic data. Is it true? Okay. So option 3. See, already we discussed. I told you, like, again I'm telling, uncertainty factor 10 is used for human variability, for extrapolation from animals to humans, for use of less than chronic data, for use of LOEL instead of NOAEL. Okay, so now you guys tell me, is option C is right, true or false? Am I audible? Okay, so option C is false. So uncertainty factor is used. Uncertainty factor 10 is used for less chronic data, less than chronic data. Okay, so here they use for more chronic data they mention, but actually it is less chronic data. So this one is wrong, false. So option B, used for NOEL instead of LOAEL. So again, actually it is used 10 is used for using LOEL instead of NOEL. Okay, again option D is false. So both correct statements are A and B. Okay, and next question. The steps for risk characterization are given below. So different steps are given, 4 steps, and select the correct sequence of this step in order to do risk characterization. So just try to arrange in correct sequence. So what are the steps? So first they were mentioning develop a framework to define a significance of the risk, present assumption, uncertainties, and scientific judgments, integrate and summarize the hazardous identification, exposure assessment, and dose response assessment. And final one is develop public health risk estimates. So which one should be come first step? Yeah, the, because it is first step you are saying 3. Yes, it is right, because for first step we do in what we do in risk assessment, identification, right? So summarizing the hazardous identification, exposure, and dose response assessment. So in answer here, three answer should be either C or D, right? So next step, which one should come next step? Develop public health risk assessment. Yes, right. Yeah, it is right answer. So develop public health risk estimates. So what is the answer now? C, right? So what is the sequence? First we have to integrate and summarize the hazard identification, exposure assessment, and dose response assessment, and then develop public health risk estimate, and then develop a framework to define significance of risk, and finally present assumption, uncertainties, and scientific judgment. It's right. The option is answer for question number 2 is C. Okay, very good. So this one is a simple numerical problem. You guys should solve by yourself. So here what they are asking, toxicity studies on rats with chronic data availability estimated that the NOAEL was 5600 milligram per kg per day for lead consumption. Calculate the safe level, sorry, calculate the safe level of dose or reference dose of lead in the case of human in milligram per kg per day. So already we gave the formula, right, for calculating the safe level dose or reference dose. So what is the formula for reference dose, safe level, for calculating the safe level dose? Yeah, safe level dose is LOAEL or NOAEL upon uncertainty factor. So now you guys calculate. So here already given NOAEL, right? That is 5600 milligram per kg per day. And then uncertainty factor we have to consider. So what are see, just read the question carefully so that we will get some idea what are the uncertainty factor we have to consider. We already discussed in question 1 itself 4 uncertainty factors here. So how many uncertainty factor we have to consider? You have to identify by reading the question carefully. So how many factors we have to consider? Uncertainty factors. So here we are talking about human beings, right? So that for human variability we have to consider 10. That is one. Again here see mentioned again rats means animal, right? Again for extrapolation from human to rats, these also an uncertainty factor we have to consider because toxicity studies on rat here. So extrapolation we have to do from animal to human being. So how many uncertainty factor we have to consider? Two, right? Both 1 and 2. These two uncertainty factor we have to consider. So now what will be the uncertainty factor? Huh? Huh? So chronic data already available. So if it is they mentioned chronic data is already available. So when we have will consider if it is less, chronic data is very less, then only we can consider. But it is mentioned that already they have availability of chronic data, means it is sufficient chronic data they have. So we don't need to consider the chronic data availability factor, uncertainty factor. Okay. So now uncertainty factor will be, what is the uncertainty factor? Yes, right. 10 into 10, that is 100. Now you guys calculate what is the answer. Reference doors answer. I need answer, direct answer. Everyone's answer I need. 56 units. Sorry, units is same because whatever the units are there for NOEL, same units will come because uncertainty factor don't have any units. So say reference dose NOEL upon uncertainty factor, that is 5600 by upon 100. So answer is 56 milligram per kg per day. Okay, now moving to question number 4. So which of the following best describes the use of deterministic approach in risk assessment? Which one is best describes deterministic approach? We already discussed, right? Which one? Like deterministic approach and stochastic approach. So in stochastic approach it is based on the probability distribution functions, and here in deterministic approach, anyone? Anyone? So it provides a single point estimate of risk. So in deterministic approach we go with single point. Okay, really? Okay, so answer is A. For deterministic approach we go with single point estimation, but for stochastic approaches we go with distribution functions, probability distribution functions. Next, question number 5. So hazardous waste management rules ensure which of the following processes given below. So whatever the options given below, 5 options, in that option what are the rules, waste management, hazardous waste management rules, which ensures. So I already discussed like different ensures in hazardous, like safe handling, generation, processing, treatment, packaging, storage, transportation, user-free processing, collection, conversion, everything. Right here, safe handling, treatment, designing, collection, conversion, packaging, and storage. So now you guys tell me what are the processes ensures by the hazardous waste management rules. Safe handling, right? Safe handling and treatment and collection, conversion of package. So the designing part is not we didn't mention designing, right? So hazardous waste management rules ensures safe handling, treatment, collection and conversion, and packaging and storage. Okay, answer is A, B, D. So question number 6, which of the following contaminants can be measured by TCLP test? Toxicity, characteristic, leachate, procedure. Test used to measure, I already mentioned, like for to calculate the heavy metal concentration we use TCLP test. For organic compounds, yes, because some toxic compounds also present in the form of organic as well. So to measure the organic compounds, what are the organic compounds present in the soil? So to measure the organic compound concentration also we do TCLP, because from in TCLP what we will get, whatever the organic or heavy metal concentration there in soil, it will be leach out into the liquid. That liquid we will take it into ICP-MS instrument. It will give results for results of heavy metal concentration. For organic compounds we will use different instruments. So like that. So generally for TCLP we do use it for both organic and heavy metal concentration, to find out the both organic and heavy metal concentration. So answer for this question is both, both A and B. Answer is C. Both A and B is the answer. So next numerical. So okay, so guys, simple question only, simple numerical. Calculate the risk due to the following carcinogens. So we just simply have to calculate the risk. So again they mention here carcinogens. So for carcinogens, what factor we consider? Reference dose or slow factor? For carcinogens we already slow factor, right? So we all for carcinogen risk how we calculate risk in for carcinogens? Slow factor multiplied by average intake. Okay, so both data given by given in the question itself, so just calculate. So carcinogen compounds given here: chloroform, chlorobenzene, BEHP, and their slow factors and average intake they give, and you calculate and tell me the answer. Everyone, I need everyone's answer. My screen is visible to everyone, right? Okay. Please solve the question. Solve this question. It is simple only. Simple formula. Just substitute all the data given in the question itself. Just what you have to do, you just have to you just have to substitute this data into the formula. The risk for carcinogens. So in that case, what you will do? So can you able to calculate risk without slope factor? No. So we don't need to consider this data because right. So now you calculate separately for chlorobenzene and BHP and then combine. We have to calculate the risk for combined compounds. Because all three are carcinogens. But for first one we are not able to calculate because we can't calculate because we don't have slow factor, and second and third one combined together we have to calculate the risk because both are carcinogens. 10 power minus 93. Okay, so everyone getting same question, sorry, same answer. Kirtana, Shrikant, Vinod. Okay, are you getting same value, same answer? So what about Kirtana? Kirtana Ramesh. I think she just joined and she muted and she's doing her business. Okay. Uh, okay. The yes, right answer is everybody getting same value. That is 6.93 into 10 power minus 10. Okay. Good. And next we'll move into the next question. And question number 8. So question number 8 seems like bigger complex and big question, but it is not. It is simple question only. Yes, all the data given, we have to just substitute the data into the formula, right? So what they are asking, a worker at a petroleum refinery site who whose weight is 75 kg and works 4 days in a week, 4 days a week on a site where soil is contaminated with chlorobenzene. Chlorobenzene again, it is a carcinogen, comes under carcinogen at concentration of 2.9 milligram per kg. 2.9 milligram of chlorobenzene concentration per kg of soil. The worker ingests soil at a rate of 195 milligram per day. 195 milligram per day, and then the fraction of soil ingested which is from contaminated site is 0.75. So fraction of soil ingested, that is also they gave for an exposure duration of 1 year. Determine the risk for tetrachloroethylene. So we have to determine the risk for tetrachloroethylene, and slow factor they give, that is 1.5 into 10 power minus 2 kg per day per milligram, and then conversion factor also they give, that is 10 power minus 6 kg per milligram. For this For this worker, assuming an average life expectancy of 72 years, the risk for TCE, that is tetrachloroethylene, is dash. So we have to calculate the risk. Again, risk we have to calculate for tetrachloroethylene. So how we will calculate risk? Again, we discuss, right? Again here it's about soil injection, right? So we calculate how to calculate the intake, soil injection intake. So how we will calculate risk? Generally soil injection into slow factor, because here it is carcinogens, right? For carcinogens, what we will how we will calculate the risk? Intake into slow factor only, right? So here they mention soil intake we have to calculate, and then whatever the slow factor they gave in the question itself we have to multiply. So soil injection formula, soil injection intake formula we already have, right? That is Ce into Rg into Cf into Fi into Ef into Ed by Bw into At. Okay, so calculate the soil injection rate and let me know the answer. First calculate the soil injection intake, everyone. So do you guys have formula, right, for soil injection? Okay, then calculate. It's a simple formula. You just have to fill the data into the form labels. That's it, and calculate. You guys already have calculator with you, so calculate and tell me the answer. Only for soil injection intake. So in first portion CE it is the 2.9 milligram per kg, right? Concentration given, right? Chlorobenzene concentration, that is 2.9 milligram per kg Ce. And then Rg also given, injection rate 195 milligram per day. And then Cf conversion factor also given, that is 10 power minus 6 kg per milligram. And then Fi, what is Fi? Fraction of ingested soil, that is from contaminated site. So that one also they gave, right? 0.75. And then exposure frequency. So exposure frequency, how you will calculate exposure frequency? So days in a year, that is generally exposure frequency unit is days per year, right? So here they gave 4 days in a week. 4 days in a week means, so how, 4 days in a week. So how we will convert in days per year? So first convert 4 into yes. So yeah. So how much you will get? 4 into 52, 208, 208 days per year, right? Okay. So EF you guys calculated, and then ED, exposure duration 1 year mentioned, and then body weight 75 kg they mentioned, and the average time, how you will calculate average time? Years they mention. So convert it into the days, 26280 days. and then you got all the data, and then just simply calculate the intake, soil injection intake. 4.47 into 10 power 10 to the power minus 8. 8. Okay, everyone getting same solution, same answer. Okay, and then just calculate the risk. How you will calculate risk? Intake into slow factor. That's it. 6 point 10 to the power minus 10. So answer here is 6.7. So now let me know, guys, is this risk, whatever the risk assessed by whatever the risk analysis done by you guys, like guys are getting around 6.7 into 10 power minus, is it acceptable limit risk or unacceptable risk? So suppose you are you guys are supposed to assess the risk of any contaminated site, and then you are getting this 6.7 into 10 power minus 10. So how will you decide whether you guys should go for remediation or not? So based on this, whatever the answer you get. So is it acceptable or unacceptable? If it is acceptable, then we don't need to go for remediation. Again, it depends on some factors, conditions. If it is unacceptable condition, then we should go for remediation. So how will how you how will how can we tell like whether we should go for remediation or not? Whether it is acceptable risk or not? So For non-carcinogens, we do calculate hazard coefficient or hazard index, right? So there what we say, if hazard coefficient is less than 1, then it is acceptable limit. It within the acceptable limit. If it is exceeding greater than 1, then it is unacceptable. In that case, we should go for remediation. And in carcinogen condition, we calculate the risk intake into slope factor. Now it is if it is greater than 10 powers minus 6. Typically, if it is greater than minus 10 power 6, then it is unacceptable. If it is less than 10 power minus 6, it is acceptable. So now it is the whatever the answer we got, that is acceptable one or unacceptable one. So 10 power minus 6, 10 power minus 10 is less than 10 power minus 6, right? So it is within acceptable limit. So right. Hmm. So next final question, I guess, question number 9. Yeah. So this is the last question for this week. Uh, so similarly, now here again, here they are asking in the past two questions, they ask about uh, risk for carcinogens. Here non-carcinogens, like hazard index or hazard coefficient, we have to calculate. The groundwater of a site is contaminated with leachate from landfill. It is having the following compounds. The waste constitute chlorobenzene and mercury. So reference dose they give and daily intake. So here the case parameter, variable parameter for measuring non-carcinogens, we consider reference dose. So for non-carcinogens, so here again, here instead of slope index, slope factor, they give reference dose. So we need that for non-carcinogens. So just calculate the hazard coefficient. How we will calculate? We already discussed the simple formula, that is hazard coefficient or hazard index is equal to intake by reference dose. So daily intake they give and reference dose also they give. Just calculate and let me know the answer. Answer is okay. Combined. You guys tell me combine answer. Like after combining the hazard coefficient for lead and hazard coefficient for mercury, you calculate separately and then combine. Final answer. Tell me the final answer. How much you are getting? Four to seven two. Okay, 4271. Sorry. 4271.23. So everyone getting same answer? Okay. So that's all about week 2 session. So please, do you guys have any doubts? So what I need, one request from you. Okay. So please don't leave the session. So just be there in live session only. But I am not going to discuss anything because as per the rules, this live session should be recorded till the 8 p.m. right, 6 to 8. So still it is 7:15 only. Just be there in online. So and I just want to record the session. That's it. Okay. Don't leave the guys. Okay. You can mute and you can do your work, but don't leave. Please don't leave the live session. If you guys have any doubts, please ask. I will be there in online till 8 p.m.